Experiment 5 Gas Chromatography GC from AS1205J that was submitted to Dr. Fariza Aina. Introducing our group members, first we have Fani Rafana, Ainur Afika, Nur Fahana, Izanur Shahira and Nurin Akila. Let's begin our presentation.
First of all, we go to the introduction. Chromatographic analysis is an analytical technique used to separate and analyze complex mixture of compounds. It works based on the movement of sample between two phases, which are stationary phase and a mobile phase. As the sample travels through the stationary phase, different components separate due to differences in their interaction with the stationary phase and their solubility in the mobile phase. Gas chromatography (GC) is a widely used chromatographic method in which an inert gas acts as the mobile phase to carry vaporized sample through a column containing a liquid stationary phase. The separated compounds are detected as they exit the column, producing a chromatogram that can be used for both qualitative and quantitative analysis. So, this is the objective of this experiment. The first one, to determine the retention times TR of N-butanol and 2-propanol. The second one is to identify the component present in a standard mixture based on the TR. And the third one is to identify the component present in an unknown samples. And the last one is to determine the effect of temperature on TR and RS.
So, this diagram shows the main components of gas chromatography system. The carrier gas transports the sample through the system and its flow is controlled by the flow controller. The sample is injected into the heated injector where it vaporizes. Separation occurs inside the column placed in a temperature-controlled oven. The separated compounds are detected using a flame ionization detector, and the signal are sent to the computer to produce a chromatogram.
I will explain about data and the result of the experiment. So look at the first graph. The GCFID chromatogram show a dominant peak at the retention time of approximately 2.72 minutes, corresponding to propanol. This peak represents 99.98% of the total peak area, indicating that 2-propanol is a major component present in the sample. A very small secondary peak is observed at around 3.63 minutes with an area of 0.017%, which is negligible. No other significant peaks or area are detected in the chromatogram, showing that no additional compounds are present in detectable amounts under the experimental condition. The peak observed is sharp and well-defined, confirming successful chromatographic separation and stable instrument performance. Second graph, the gas chromatography GC analysis of the N-butanol sample show a single dominant peak at the retention time of 6.04 minutes, accounting for 99.85% of the total area, indicating that N-butanol is the main component and the sample is nearly pure. Two very small peaks at 2.66 and 2.93 minutes, each contributing less than 0.2% of the area, likely represent minor impurities or residual solvents. The sharp and symmetrical main peak confirm good separation and accurate detection, making this retention time a reliable reference for identifying N-butanol is another sample. For the third graph, the gas chromatogram of the standard mixture shows three distinct peaks at retention time, that's 2.692 minutes, 2.929 minutes and 5.903 minutes, confirming that the mixture contained 3 different compounds. Each peak represents a compound that was separate as it passed through the GC column. Based on the area present report, the peak at 5.903 minutes has the largest area, where 63.01%. indicating that this compound is the major component of the mixture. The peak at 2.692 minutes contributing the 36.98%, making it the second most abundant compound. The peak at 2.929 minutes has a very small area, that 0.012%, showing that this compound is present only a trace amount or as an impurity. This difference in retention time occurs because each compound has different volatility and interaction with the stationary phase of the column. These retention time are used as reference value to identify the same compound in the unknown sample. The GC result for the standard mixture show 4 discrete peaks at retention time of 2.269, 2.405, 2.620 and 3.294 minutes, indicating the presence of 4 components in the sample. The peak at 3.294 minutes is the most dominant, contributing at 62.79% of the total area, followed by the peak at 2.269 minutes with 36.19%, showing that these two compounds are the major components of the mixture. The remaining peaks at 2.405 and 2.620 minutes have very small R percentage at 0.0136% and 0.0073% respectively, indicating that they have presented only in trace amount. Last graph show the GC result for the standard mixture at 140 degrees, show 3 detected peaks with retention time of the approximately 1.952, 2.225 and 2.930 minutes, indicating the presence of 3 components eluates under 3 conditions. The peaks at 1.952 and 2.225 minutes are sharp and have much higher signal intensities, showing that these 2 components are the major components of the standard mixture. The peak at 2.930 minutes is very small, indicating that this compound is present only in a trace amount. Overall, the chromatogram demonstrates faster eluates compared to lower temperatures, with clear peak separation and well-defined retention times for identifying the component of the standard mixture.
Next, I will explain the discussion of this experiment. To identify the peak of the unknown chromatogram, the retention time were compared from the standard mixture. Each compound has a unique retention time under the same condition. So match this value allow us to assign the correct compound to each peak. Peak area and height support this identification, showing which compound were present at higher concentration. The column temperature strongly affect retention and resolution. By lowering the temperature will increase the retention time and improve separation, but it will make run slower and peak border. By raising the temperature, we shorten the retention time and produce a sharp peak. Through the resolution may decrease the compound closer together. The best result will come from the balancing speed and clear separation.
In conclusion, the retention times of 2-propanol and N-butanol were successfully determined. The standard mixture and unknown sample were identified based on retention time comparison. The effects of temperature on retention time and resolution was also observed. Therefore, all objectives of the experiments were achieved.